So for our last section in this unit, we're going to be looking at what are called geometric sequences. Now, do you remember when we talked about before, which are arithmetic sequences? Let me just remind you. So we have what are called arithmetic sequences when you add the same number to each term. So you could be adding 1 every time, adding -5 every time, or adding 1/8 every time, but you're adding or subtracting, and this creates a linear relationship or a linear function. So what we're going to be looking at today is we're looking at a geometric sequence. And the difference between arithmetic and geometric is simply in the operation. So we are going to be multiplying. So you can see this is multiplication. And the number that we're multiplying is called the common ratio. Just like how the number we added was the common difference before for arithmetic, we're looking at a common ratio. And this creates an exponential function because we're multiplying every time. So that's why we're looking at geometric sequences here. Okay, so if we take a look at the first example, you want to tell the difference between geometric, arithmetic, or also what if there's no relationship at all, and that would be neither. And you want to be able to explain your work. So if you take a look at example A, what's happening between 8 and 24? Well, you might say, okay, well, 8 plus 16 is 24. Is 24 plus 16 72? Well, no, because 24 plus 16 gives me 40. So then I might think, okay, let's try multiplication. Well, 8 times 3 is 24. 24 times 3 is 72, and 72 times 3 happens to be 216. So since we have a common ratio of, I always want to say ration, so common ratio of 3, then we know this is geometric. So again, because there is a common ratio of 3. You can also say each term is being multiplied by 3, and that's fine because that explains what a common ratio is. Okay? If you take a look at B, let's think what's happening as we go from 8 to 3, 3 to -2, -2 to -7. Well, you might think, well, 8, what do I divide 8 by to get 3? Well, maybe I don't want to think about that, and I want to say, well, let's see if it's arithmetic first. So let's see if I added the same value each time. So 8, well, plus a -5 is 3, and 3 plus a -5 is also -2, and hey, look, that common difference works out. I subtracted 5 every time, or I added -5 every time. So this common difference now tells me that we have an arithmetic sequence. So again, arithmetic, because there is a common difference of 5, or -5. And you could also restate that. If common difference, common ratio sounds too similar, you can say, well, you subtracted 5 every time from each term, or added -5 every time from each term. Okay? So go ahead and try the you-try problems 1, 2, and 3, doing the exact same thing, telling me if it's arithmetic, geometric, or neither, because it could be neither, and explain why. All right, go ahead and check your work. So hopefully you saw that 1 is arithmetic because it's going down by 4 every single time. 2 is geometric because we're multiplying by 1/2 every time. And 3 is neither because it was suddenly +4, then +6, so there's no common difference or common ratio. And again, your explanations could be different, right? But this is just one possible way you could have explained your work, but it's really important you are telling me why, okay? Let's take a look at extending these geometric sequences. So now that we know how to find a common ratio or for our geometric sequences, let's determine what the next terms are. So if you look at example C, we want to figure out what are the next 3 terms. Well, the first thing you want to do is figure out your common ratio. And if I'm looking at C, it's going from 80 to 40 to 20, so it's going down by half every time. So that's a 1/2. And you can go ahead and make this a table if you want, or you can just do the division and list out your terms if you want. But here we have your term number, right? And then the actual value, which I'll call n, Or actually, let me go ahead and do a sub n, so we're using the same notation as our arithmetic sequences. And this is not 1, but n, the number in our term. So the first term was 80, the second term was 40, the third term is 20, the fourth term is 10. Then I want to do the fifth term, so I'm going to divide by 2 or multiply by 1/2, which will give me 5. Then the sixth term, I want to multiply by 1/2 again. 5 times 1/2 is 5 over 2. And then my seventh term, which is where I want to stop, I'm going to multiply by 1/2 again. And if you need to do this on the side, you can, but just multiply straight across the top to get 5 times 1, which is 5. Straight across the bottom, which is 4. So my next three terms are 5, 5 over 2, and 5 over 4. Again, you don't have to do the table. The table's kind of nice if your work is all scattered and it's hard to read your own writing, but you can always just do the division on the side or the multiplication on the side, okay? So if we take a look at D, let's find that common ratio. And if you're not really sure, well, you'll see it's going down. It's going to be a fraction, and it's going positive, negative, so we know it's going to be a negative value. And I can just do some division and be like, well, 16 divided by 4 is 4. 4 divided by 4 is 1. Is 64 divided by 16 4? And I can just check that really fast. 16, and just guess and check. 4 times 6 is 24. Yep, that works out beautifully. So I know the common ratio is negative 1/4. And you can do the table again if you'd like, or if you just want to do your work on the side, here's a sub 1, 2, 3, 4. So a sub 5 is going to be negative 1 times negative 1/4, which is positive 1/4. A sub 6 is going to be 1/4 times negative 1/4, which is a negative 1/16. And then a sub 7 is going to be negative 1 over 16 times negative 1/4, which will give me positive 1 over 64. So the next three terms are 1/4, negative 1 over 16, and positive 1 over 64. Okay? So it doesn't matter how you do your work. What's important is you do get those three terms and your work is readable, right? And I can follow it. So go ahead and try 4, 5, 6, and 7. Find those common ratios and then find the next three terms for each sequence. All right, go ahead and check your work and see if you got those common ratios and then you applied it to get 48, 96, 192 for 4, 4, 4/5, and 4/25 for number 5, 5, negative 5 halves, and 5/4 for 6, and negative 32, 64, negative 128 for 7. We will finish this in class on how to write the function, which hopefully you'll think about and remember it's going to be exponential. Okay, thanks for listening.